Good morning, everyone. My name is V. Pawansai Srinivas. I am from CSIT B section. My roll number is C7. Today's my topic is nodal analysis on electrical circuits. Before going to the topic, what is meant by nodal analysis? Nodal analysis is a method that provides a general procedure for analyzing circuits using node voltages as the circuit variables. Nodal analysis is also called the nodal voltage method. Some features of nodal analysis are as nodal analysis is based on the applications of Kirchhoff current law, that is KCL. Having n nodes, there will be n minus 1 simultaneous equation to solve. Solving n minus equation, all the node voltages can be obtained. The number of non-reference nodes is equal to the number of nodal equations that can be obtained. Types of nodes in nodal analysis. Non-reference nodes. It is a node which has definite node voltage. Example, here node 1 and node 2 are the non-reference nodes. Reference nodes. It is a node which adds a reference point to all other nodes. It is also called the datum node. Types of reference nodes. First one, chases ground. This type of reference nodes acts as a common node for more than one circuits. Another reference node is earth ground. When the earth potential is used as a reference in any circuit, then this type of reference node is called ground earth ground. Solving of a circuit using nodal analysis. Basic steps used in nodal analysis. Step, select a node as the reference node. Assign voltages V1, V2 up to so on and Vn minus 1 to the remaining nodes. The voltages are referred with respect to the reference nodes. Apply KCL to each of the non-reference nodes. Use Ohm's law to express the branch current in terms of node voltages. Here I1 refers to current source and I2 refers to second current source. R1, R2, R3 are the resistors and V1, V2 are the reference nodes and I2 are the current flowing from I2 source and I1 is a current source from the I1 point. When the combination of I3 is equals to I1 plus I2. Node always assumes that current flows from higher potential to lower potential in resistor. Hence the current is expressed as the follows. I is equals to V high minus V low by R. Next, after the application of Ohm's law, get the n minus node equation in terms of node voltages and resistance. Fifth one, solve n minus node equation for the values of node voltages and get the required node voltages as result. Nodal analysis with current sources. Nodal analysis with current sources is very easy and is discussed with an example below. Example, calculate the node voltages in the following circuit. Here we have 5 ampere current source and 10 amperes another current source and 2 ohms and 4 ohms and 6 ohms are the resistors and V1 and V2 are reference nodes and this is at the reference and I1 is divided to I2 plus I3 and I4 is again divided into I5 minus I4. In the following circuit we have three nodes from which one is reference nodes and another two are non-referent nodes, node 1 and node 2. Step 1. Assign the node voltages as V1 and V2 and also mark the directions of the branch current with respect to the referent nodes. This is the discussed above diagram where this is the reference node to eliminate any type of fluctuations. Step 2. Apply KCL to the node 1 and node 2. KCL at node 1, that means I1 is equals to I2 plus I3, that is equals to KCL at node 2, that means I2 plus I4 is equals to I1 plus I5 is second equation. Step 3. Apply Ohm's law to KCL equation. Ohm's law to KCL equation at node 1, where I is equals to I2 plus I3 is equals to 5. V, that is equals to V1 minus V2 by 4 plus V1 minus V0 by 2, where I is equals to V by R. By simplifying the above equation, we get 3V1 is equals to 20 plus V2 in third equation. Now Ohm's law to KCL equation at node 2. I2 plus I4 is equals to I1 plus I5. We know that I is equals to V by R, where I1, I2 is divided to V1 minus V2 by 4 and I4 is given in the diagram, that is equals to 10. I1 is equals to, that also given in the diagram, 5 plus V2 minus 0. 0 means reference node by 6. By simplifying the above equation, we get minus 3v1 plus 5d2 is equals to 60. That is equals to fourth equation. In step 4, now solve the equation 3 and 4 to get the values of v1 and v2 as using eliminating method. 3v1 minus v2 is equals to 20 minus 3v1 plus 5v2 is equals to 60. 3v1 and minus 3v1 can cancelled and 5v2 minus 5v2 is equals to 4v2 and 60 plus 20 is equals to 80, where v2 is equals to 20 watts, and substituting value v2 is equals to 20 watts in equation 3, we get 3v1 minus 20 is equals to 20, where V1 is equals to 40 by 3, that U is equals to 13.33 watts. And node voltages are as V1 is equals to 13.33 watts and V2 is equals to 20 watts. Nodal analysis with voltage sources. In voltage sources, case 1. If a voltage source is connected between the reference node and a non-reference node, we simply set the voltage at the non-reference node equal to the voltage of the voltage source, and is analyzed can be done as we done with current sources, where V1 is equals to 10 volts. Case 2. If the voltage source is between the two non-reference nodes, then it forms a supernode whose analysis done as following. Supernode analysis. Definition of supernode. Whenever a voltage source, whether it is independent or dependent, is connected between the two non-referent nodes, then these two nodes form a generalized node called the supernode. So supernode can be regarded as a surface enclosing the voltage source and its two nodes. In this circuit, V2 and V3 have common voltage source, that V voltage. This is known as the supernode. In the above figure, 5 volt source is connected between two non-referent nodes, node 2 and node 3. So here node 2 and node 3 form this supernode. The properties of supernode are always the difference between the voltage of two non-reference nodes is known as that supernode. A supernode has no voltage of its own. A supernode requires application of both KVL and KCL to solve it. Any element can be connected in parallel with voltage source form the supernode. The supernode satisfies the KCL as like a simple node. How to solve any circuit containing supernode? Let's take an example to understand how to solve circuit containing supernode. Here V1 and V2 are the supernodes. In between there is a voltage source and 2 amperes and 7 amperes are the current sources where resistors of 10 ohms and 2 ohms and 4 ohms are given, and this is a reference node. Here towards source is connected between node 1 and node 2 and it forms a super node with a 10 ohms resistor in parallel. Note: any element connected in parallel with the voltage source forming supernode does not make any difference because V2 minus V1 is equals to 2 volts. Always whatever may be the value of resistor, thus 10 ohms can be removed and circuit is redone and apply KCL to the supernode as shown in the figure below. In this, the above 10 ohm resistors is removed because V2 minus V1 is equals to 2 volts. Whatever will be the value of resistor will be same. Then the resistor can be removed. And thus after the removing of 10 ohms, the circuit diagram will be like this. Expressing and in terms of node voltages. 2 is equals to V1 minus 0 by 2 plus V2 minus 0 by 4 plus 7, that is equals to 8, that is equals to 2V1 plus 2V2 plus 28, that usualized to V2 is equals to minus 2V1 minus 20, that is equals to fifth equation. By given circuit we can observe that from V1 to V2 the supply is going on. Then V1 plus 2 minus V2 is equals to 0, where V2 is equals to V1 plus V2, that is equals to 6. By solving 5 and 6, we can write as V2 is equals to V1 plus 2, that is equals to 2V1 minus 20, that is equals to 3V1 is equals to minus 22. V1 is equals to minus 7.33 watts and V2 is equals to V1 plus V2, that is equals to minus 7.33 plus 2, that is equals to minus 5.33 watts. Hence V1 is equals to minus 7.33 watts and V2 is equals to minus 5.33 watts, which is required as answered. This is about the nodal analysis. Thank you for giving this opportunity.